Hello, I'm Ian. Welcome to my channel. Hi. So last week I talked about social history, something that I've got absolutely no background in, technical training. This week I'm going to be talking about science and what science is and what science isn't. And although I do have a science degree, I'm not a philosopher of science and nor do I have any training in that capacity. Whether what I say makes any more sense, I'll leave that for the viewer to decide. Here's a spoiler alert. By the end of this video, you probably won't know what science is or what science isn't, but I hope you'll be a little clearer as to understanding these issues. We often turn to dictionaries when we want to find definitions, but this is actually a mistake. Dictionaries are about usage, not definitions. And there are general problems with definitions. Here's a dictionary definition of science. Knowledge ascertained by observation and experiment, critically tested, systematized, and brought under general principles. So what's the problem? Well, what's the definition of this word? And what's the definition of this word? And, well, we carry on. And this word, and this word, and this one, and the next one. And, why stop there? We can carry on and look even further down and say, what's the definition of this word, which is talking about the definitions of words. So this is where dictionary definitions become complicated and, generally speaking, unhelpful. There are other types of dictionaries, of course. I have a Dictionary of Earth Sciences, which tells me, amongst other things, that lazulite is an ultramafic rock consisting largely of olivine together with orthopyroxenes and clinopyroxenes. I think you'll find that information very helpful for resolving any number of pub disputes. I also have a Dictionary of Saints, where we can find the following reference to Ethelreda, or Audrey, and are told that Ethelreda was succeeded as abbess by her sister, Saint Sexburga, for all those of you who doubted that there was a Saint Sexburga. I wonder what it was like having two saints in the same family. Did they argue, as I understand sisters are wont to do? Probably not. Still, we shall never know. But I digress. Let's get back to the main point of this talk, which is about science. And not only do dictionaries not define science, but there is no authority to tell us what science is. Not the Royal Society in London, not the Karolinska Institute, who award the Nobel Science Prizes, not even the US Congress. So does this mean we can't say anything about what science is then? Well, it's not stopped anyone in the past from telling us what science is, but here are a couple of references that I quite like. This first one is from the physicist John Simon. Science is to be believed because it can be openly criticised. The criteria for belief is not authority nor logical necessity, but nobody has yet found a more convincing pattern of interpretation. And this quote from John Cleese has many admirers, but also those who criticise it. Cleese studied law at university, but has A-levels in maths, physics and chemistry. But some scientists appear to contradict themselves. Here's Nobel laureate Paul Dirac, and this is what the poet John Keats had to say about it all. A lot of the discussion about what science is has been conducted by philosophers. Here are some examples. The books by Popper and Kuhn in particular being particularly important and influential. Mary Midgley, a noted British philosopher of the 20th century, was said by the Guardian newspaper to have pricked the pretensions of science. But they don't say anything about the pretensions of philosophers or even the pretensions of journalists. She compared philosophy to plumbing, saying that you only call on them when you need them. Now, if I had a leaking tap, I'd call a plumber. And if he couldn't fix it, I'd call another. But if, after more than 2,000 years and innumerable plumbers later, I still had a leaking tap, I think I'd give up on plumbers and try a different solution. Well, if we have a problem defining science, what about the scientific method? So this is an abridged version taken from a talk by Richard Feynman, a Nobel Prize-winning physicist. It says, first, make a guess, which is frame a hypothesis. And this hypothesis must explain all the known evidence. Secondly, you make a prediction. And thirdly, you compare the prediction with observation, which is essentially experiment. Seems simple enough. What do other scientists say? This is Steven Weinberg, another Nobel Prize winner and a friend of Feynman. Quoting from essays, I know enough about science to know there is no such thing as a clear and universal scientific method. All attempts to formulate one since the time of Francis Bacon have failed to capture the way that science and scientists actually work. Here's another quote from the same collection of essays. Not only does the fact that the standards of scientific success shift with time make the philosophy of science difficult, it also raises problems for the public understanding of science. We do not have a fixed scientific method to rally round and defend. I remember a conversation I had years ago with a high school teacher who explained proudly that in her school, teachers were trying to get away from teaching just scientific facts and wanted instead to give their students an idea of what the scientific method was. I replied that I had no idea what the scientific method was, and I thought she ought to teach her students scientific facts. She thought I was just being surly. But it's true, most scientists have very little idea of what the scientific method is, just that most bicyclists have very little idea of how bicycles stay erect. In both cases, if they think about it too much, they're likely to fall off. So it appears that defining science and scientific method are a bit like trying to define comedy. For example, both Love's Labour's Lost and On the Buses are called comedies, but what connects them? Other than the fact that no one's laughed at either for the past 400 years. So, if we can't define science or the scientific method, how do we do science? Well, to borrow an analogy, in much the same way that farmers can produce beef without being able to define what farming is or what a cow is. What matters is solving the problem. So, having just kicked philosophy in the ballcocks, I'm about to philosophise on what science is. This is known as irony. Here's a simple definition. Science is an objective way to explore and explain the universe. And the emphasis is on objective. Objective means that anyone, irrespective of their cultural or religious upbringing, can evaluate and agree. This is not new. This argument goes back to Francis Bacon in the 17th century. And don't take my word for it. Here are a couple of rather more significant opinions. What are the assumptions of science? There is a real world. It is rational, it is observable, it is consistent. There are no other assumptions. Let's get back to our definition. Science is an objective way to explore and explain the universe. This is David Deutsch, Professor of Physics at Oxford University's take on it. The purpose of science is to understand reality through explanations. The characteristic method is experimental testing. So science requires explanations and predictions, but we can explain everything. Let me give you an example. How did the ancient Greeks explain this phenomenon? They said that the sun god, Helios, carried the sun in his chariot. This is an explanation. We probably don't accept this today. Why not? So, what is an explanation? Here's Professor Deutsch again. A statement about the nature of things and the reason for things. They are justified by their superior ability relative to rival explanations to solve the problems they address. But this raises another question. Who decides what is the best explanation? In the philosophy of science, there's a controversial view about the concept of consensus. In the legal system and many other similar systems, a jury decides on the evidence. There is something similar in science, except that the jury consists of fellow scientists and the verdict is always open to another trial. With most of the explanations in traditional science, there is almost complete agreement. But this is not the case for some topics at the forefront of our understanding, such as string theory, the interpretation of quantum mechanics, just to give a couple of examples from physics. Why do we need predictions? A hypothesis must explain all known phenomena, but as we've seen, we can always explain things that are known. For a hypothesis to be accepted as science, it must make testable predictions. It's the only way we can distinguish between competing hypotheses. The concept of falsifiability as necessary for a scientific theory was introduced by Karl Popper in the book I mentioned earlier. Here are some scientific theories. Are they falsifiable? This does not mean that evolution is true and string theory and psychoanalysis are not. It is just that because it is difficult, if not impossible, to disprove string theory and psychoanalysis, they are not useful as explanations. But I should add that not everyone will agree with it. So this brings us to facts, theories and laws. We hear these terms used with regard to science all the time. Regrettably, they are often used incorrectly, even by those who should know what they're talking about. The term fact is rarely used in professional science papers. More usually the words observations or data are used. Here's a good explanation from the American Association for the Advancement of Science. A scientific theory is a well-substantiated explanation of some aspect of the natural world based on a body of facts that have been repeatedly confirmed through observation and experiment. I'll leave you to read the rest. And here they deal with that ridiculous cliche, evolution is only a theory. These statements speak for themselves. What are laws in science? Here are a couple of well-known laws in physics which we all learnt at school, or we should have done. They're encapsulations of very many observations and they're often given in mathematical form, but they are not explanations. And you can see that I've emphasised this by sticking a nice banner across the page. Here's a summary from Wikipedia. Scientific laws summarise the results of experiments or observations. Scientific theories explain why something happens, whereas scientific laws describe what happens. What about mathematics? Why do we need mathematics? Well, here are my 3 reasons. We need mathematics to calculate the accuracy of our observations. We need mathematics to reduce the ambiguity over our terminology. And finally, mathematics is universal. It's the same in English, Chinese, French, whatever language you like. When I was studying for my PhD, I came across an important paper that was written in Japanese. Now, I don't speak a word of Japanese, but I could understand the mathematics, and that was what was important. A commonly used analogy is the jigsaw puzzle. Here's a rather exquisite 3-dimensional one. If we have a piece in the wrong place near the top, it's fairly easy to replace it. But if it's at the bottom, effectively the foundations of the puzzle, then it's a problem. And so it is with science. The pieces at the top, the new hypotheses, can be easily discarded if they don't fit, but the foundational theories are much more difficult to dislodge. They support the whole body of science and have been tested many times and proven themselves. As Carl Sagan said, extraordinary claims require extraordinary evidence. Here's a stereotypical old woman uttering a phrase that I've heard more than once. Science can't explain everything. Of course it can't. That's why there are thousands of research scientists around the world. They're not researching what we know, they're researching what we don't know. There is a deeper question though. Are there things science can never explain? We don't know. We just keep on looking. Thank you. Thank you for watching my second YouTube video. I trust you found it informative. Please leave a comment below, and I particularly welcome comments from plumbers. Hit the like button if you liked it, and please hit subscribe and hit the bell to receive all notifications. And I hope you'll see me again in future in my forthcoming video. Thank you.